class on lines. That is a part of whole forms. Right? So today we will maybe covering the 5.1 and 5.2 whole form definitions, and lines and hydrostatic will be covered next year. This is I took from museum, National Museum of Korea. This is coming from 1592, a long time ago. How many years? 420, 30 years ago. There was a war between Japan and Korea. And the turtle ship looks like a turtle, was famous at the time. And probably this looks like a main leader's ship, commander ship of Korea, because this is picture from Korea. And I guess the top side can be the Japan ships. I'm not sure that there is another picture that is coming from Japan side, right? You may not notice that, but we share the Korean Japanese characters, but there are some Japanese characters too. Chinese character and Japanese character together. So this looks like a commander ship of the Japan and then small ships. So two groups of, you see that flag is big flag of Japan. And fighting each other at the Korean Ocean, near the Korean Ocean. So this is a whole form of ship at the time. 400 ago. At the time there was no engine, no car, no train, right? Only ships. They use only wind and rowing, right? But the Korean ship side, this is Korean side, Korea turtle ship, and this is Japan ship. You see it from the picture. The form is very wide and short ship. Turtle looks like this one, right? Turtle is a rounded shape. And Japan ship is narrow and long, skinny to each other. And the property is that because it is wide, this is stable. Stable means that it can be easy to, right? And then also have a area, fat ship. But this one is very narrow, so that slender. It is easy to propel toward the wave and water. Cost-wise, this is easy to build. It is flat and round, but there is no engine. But I'm saying the power. You can say power. It should be modified to power. Small power is required, or faster, or small power. So that it is coming together, slow speed, and this is high speed. And if goes on to rough sea, it is not good. Right? Sea sickness means ship coming. And this one is good for, because it's sharp, so that can piercing the wave. Right? So looks, this ship is better, right? High speed and good seaworthiness. But the battle was different, the result. Right? Why? But there is another story there. But anyway, because this ship is intended to use near coastal line, that's why they don't need to have a slender body. This one, they need to come to Korea, and the distance is not far away from between Japan and Korea, but the sea was rough between them. And also, Japan is an island that was compared to Korea. That's why they need to have a ship in, right, in high speed. So that's why the differences are coming. The background, can you remember kind of one from the hydrodynamics class? Right? Drag coefficient, drag coefficient. So blunt shape, something like a square is highest, right? Or right, short cylinder. Short cylinder means this way, right? Higher. Then the circle or minimum is streamlined body, right? Very big difference, right? 25 or 30 times difference, drag coefficient. That's why we are doing slender body shape, right? Rather than blunt body. And narrow and sharp edge at the front to reduce drag coefficient. So another one, same one, but with a different viewpoint, drag coefficient, and also the equation, and the frontal area is important. Right? So blunt one is very high, right? And this one is good, aerofoil. So you remember the hydrodynamics you already learned from another class, right? This is looks like a miniature battleground, and in a model pool of water, right? With waves are also generated. So this is looks like a turtle ship. I guess this is a Japanese warrior or something. I don't know. Right, right, right. And this is another comparison, but I copied from another person's one so that Korean characters are still there. But I translated, right? Turtle shape, but this one is before the coverage of the top face. So we call this a panokson. So you may expect that this turtle ship, the baseline is the ordinary vessel, but they make another technology to covering that try to protect from the Japan warriors coming into the ship. Right? So we call this is a protection and cladded and steel plate cladded. But the big difference coming from they use guns, big guns. Right? Rather than Japan warriors use short range rifles rather than cannon. So that you can expect that they want to be fight far away, right? Long range gun is coming. And Japan want to come to the close to the ship and fight nearby, right? Using rifle and then knife. So tactically, they have differences. And speed is high, right? Speed is high, slow. But they need a wide deck area and stable deck area because of their gun, big cannons. Otherwise, ship is capsizing, right? Because of the cannon create a force back. So that's why I'm trying to explain why the difference is coming from hull shape. Hull shape is different in the war time. This is a typical design requirement. Owner means a ship owner that ordered a ship to construct in a shipyard. Similarly to myself, I ordered home, two floors home, to construct car constructor. So I was a homeowner and requirement set to the constructor. We have a contract to build my home, very similar to building a ship. Right? So key requirement can be a ship type. It can be a yacht, it can be a racing boat, it can be a cargo ship, it can be a submarine. And then usually the cargo weight is important for the cargo ship. Or capacity means say cruise ship, how many passengers? That is important, right? Because that is the money coming. How many passengers we can accommodate, or how many containers, TEU, or how many soldiers, or how many missile or torpedo. Right? That can be the capacity in general, and speed, and limitations. Something like the ship should enter to the Sydney port. That Sydney port has a bridge, so that they should under the bridge, so the height should be minimum in this way. And biggest limitation coming from the canal. Uh, what is the name of the Panama Canal? And Egypt Canal. What is the name of the Egypt Canal? Suez Canal. Right. The kind of. Right. So the limitation coming from the breadth of passageway, and also the depth of the water passageway. This is a man-made channel. So design limitation. Also limitation coming from the pollution, right? Pollution, we studied on Monday, right? About pollution limitation. MARPOL or safety requirements, pollution requirement, and also special requirement. So pollution requirement, another one, CO2 efficiency. Right? But this is just a rough comparison because this is a big ship, biggest ship, so that per ton, you need to know that ton kilometer divided by gram CO2 generation. So that small one is not good, right? So truck is smallest, and rail, and smaller ships, and then big ships. So that, but you can see that the size difference is 100 times. Green ship concept. NYK is Nippon Yosen Kaiken, so it's a Japanese shipping company, and they provide a new concept ship, looks like this one, and they use wind energy, and also solar energy, solar plate, and you can see that this is submerged part, so that they have a less, how can I say, the wave forces to the hull. And then 8,000 TU fuel cell, right? And then solar and wind. Right? So that CO2 emission is very good. They use this. It is not constructed yet. This is just concept ship. And whole form definitions. So linear measurement is the length and breadth and depth. You already see this. And also 2 and 3 dimensional coefficient. We call this is a whole form coefficient. We'll see later more. And speed, also relative means not absolute speed. Is a relationship between divided by something. Okay? Whole proportion is coefficient. Ooh, there's a Korean character, but I just want to show that there are not one single length. This is our 3 different length measures, important for it. You need to memorize this. Length overall is altogether the maximum, tip to tip, right? Tip to tip, LOA. And length waterline is, this is waterline, right? But waterline is changing as cargo loading is changing, right? Every time. But we know that maximum draft, or we call this is a design draft. Right? Design draft is the maximum draft. Limitation. So we call this is a design load line or water line length, right? LW. And LBP is more important for shipbuilders company, shipbuilding company, because between AP and FP. But this is a short name of after peak, and this is a full peak. Why? Because they construct the ship based on this length. And they usually divide this length into about 20 stations. And then also more on, say, 150 or 200 divisions. Right. So each one, you may see this small ticks, right? This is some meaningful measures. So they equally divide that ship into several numbers because they want to do some transverse frame. Transverse frame is similar to this one, right? Rib. Right? So how many big rib and small rib is constructed for per ship is decided by designers for the structural reasons, right? Strength. So that's why they use this one is important. Also, each depart or compartment or hold is divided by based on these frames. How many ribs? Right? Very simple building. Building have pillars, important uh, uh, structure, important construct, important, and also walls. Main walls are some walls are very important structural reason, and some walls are just for decoration, divided. For when you find the room, or you may use it. Structure cannot be modified. You need, if you want to modify the structural parts or you need to get permission again, calculation again, and permission. So that they use this kind of divisions, important for the constructor and structure. That's why they use a classification society and insurance and tax are coming based on this length. But this one is important for hydrodynamics, motion, resistance, propeller, something like that. Hydrodynamics, water is related, motion is related. But this one is for construction and structure. Question? Right, structure. Transverse hull form, right? Transverse midsection. And this looks like a bulk cargo ship midsection. Bulk carrier. Grain carrier, coal carrier, or ore carrier. Why? Because of this shape. I noticed, you may not notice. This is good for grains, right? They pouring grain to the entrance, right? The shape looks like this way, right? This way, looks like this way. So without this shape, usually they have an empty space, right? And then if you have an empty space, ship is rolling, then cargo is shifting. So that's why they use another. This can be used for another reason. Depth draft is already explained to you, so I don't need to. And breadth and baseline. And there is two draft lines, right? Design draft and scantling draft. Very similar, very small differences. Sometimes it's the same, but this is based on structural design. And this is for cargo capacity and hydrostatic calculation. Right. So dead weight calculation, speed and power. This is structural design. And this is a molded something. And extreme, where is it? Molded something is coming. Where is it? No, no, not in space. Right. See, the molded means this plate, this steel plate is about thickness. Thickness, did I told you about thickness of the chip plate, steel plate? Yes. How much was? 2 centimeter. Good, good student. Right. Right. How about automotive? 2 millimeter, less than 1 millimeter. The outer skin, There are more thicker pieces inside the car, but I mean the outer skin, right? So the molded means excluding shell plate thickness. The 2 millimeter is excluded. So inside the line or outside the line, right? Very small change. But in terms of whole volume, it's several tens of tons. That gives you big difference for the money and cargo, displacement, and also other things. Right? Cargo capacity. Right? 1,000 kilogram, 1-ton truck. This is 1-ton truck. It is very famous truck in Korea, Porter. Right. Very same as cargo ship. Right? They need to have a maximum cargo capacity. That is a dead weight or payload. So it is maximum cargo 1 ton can be loaded in this truck. And her form structural shape very complex. So this is a double bottom tank top plate, and double bottom is very complicated because of, and this is a frame. Right? I explained this one. Each frame, right? And sometimes there is a bigger frame. So maybe here and here, maybe 3 times, 4 times larger frame is coming. So main frame and smaller frame between. Right? That is each time LBP is divided by this frame spacing. So we call this as frame spacing. It's based on LBP divided by 200 or 120, depending on the ship, right? Or structural design. Right, molded is coming, right? Molded means, did I say including or excluding? Molded. Can be there is no example. And waterline, freeboard. But this one is very strange ship, but this is an empty ship, I guess. Right? So this is not design waterline, empty water. Dead rice, something more dead rice. Small terminology, and this one is for wood ship. The turtle ship is made of wood long time ago. So now there is no such a wood ship anymore. Nobody uses wood ship. Very special, all the traditional persons are using this one, but this is not for normal or day life ship is FRP, aluminum, steel. Right? No wood. But still, there are person who is making a wooden ship and old ways. Weight, you already know this, right? Lightweight. Total hull steel weight, and equipment also. Right? So it's a weight when the shipyard finish the ship construction. Right? Lightweight. Right? No cargo, no passengers. Right? Only bear. So says when you have your new car delivered just delivered to you, right? This is an empty car, is a light car, lightweight of the car, right? Same as this. And dead weight includes cargo and then some more, something oil, fresh water, and crude, and crew members, and luggage, and or lubrication oil in the engine and something, right? So displacement, I already explained that. So lightweight ship, dead weight plus, and then this one is this one, right? And this is a distribution along the LVP, but BP is here, so there are a little bit more. So ROA can be ROA, right? ROA, and weight distribution along the length line, right? This is weight. You need to calculate this one. You need to draw this one as a ship designer. So area of this curve can be total weight of the ship, right? And then displacement is coming from buoyancy, and buoyancy coming from the pressure coming from the water, right? That should be balanced together, right? Weight, including all cargo and others, right? Whole cargo, and then, so this one can be many different, not many, several different curves. Lightweight curve, cargo curve, and altogether curve. And also loading condition. Loading condition means some cargoes, some of the containers loaded, unloaded, right? At the Singapore port, at the Busan port, at Los Angeles port, loading and unloading. So changing, right? Changing. And fuel is used, fuel is loaded, refueling, rewatering. Every day is changing, right? So curve weight is changing every day. But you need to calculate typical curves for your design. Bulwark means shape at this portion, we call it. But this one is angled and straight up, right? Angled and straight. Vertical type, but the slanted one means this type. This is a rounded shape, this way and this way. So two different types, and bow, bulbous bow. Okay. Question? No question. This one? And I always wonder, why does the spot look like that? Why do you think it like that? This bulbous bar. Bulbous bar. This is another good topic for explanation. But simple answer is that the wave, cosine wave, and sine wave, and together equal no wave, right? Simple idea. So this one can generate another wave. When there is no bulb, the ship generates wave, right? But by adding this one, we can somehow canceling each other. There is an idea of bulbous bar. But sometimes it works, sometimes it doesn't work. Because phase difference between waves is not easy to match each other, right? Right? And size also, length, size, phase, all should be same, right? To canceling each other. But anyway, the baseline idea is this. Long time ago, Roman ship, they do this one, but this one is for attacking, puncturing the wooden ship at the side. Right? That is not for the wave race, but modern ships is for this side. Any other questions? Come on.